The title of my talk is Creativity, Machine and Poetry. Some of these words don't tend to appear together, so it might not make sense immediately, but hopefully they'll all make a little bit sense after the talk. You can see myself in the top left corner, Jey Han, and here are some of my colleagues who worked in the project, Trevor, Tim, Julian, and Adam. Most of us are computer scientists, with the exception of Adam, as you can see there. He's the literature expert, he's the English professor. He's basically the adult in the room who keeps us kids stay focused and stay on the right track. And you can see he has a much more serious face than most of us. So what is creativity? I looked it up. Wikipedia gives me a fairly good definition, so I stole it. Creativity is a phenomenon whereby something new and somehow valuable is formed. The created item may be intangible, or it could be a physical object. A fairly reasonable definition of creativity. Now, what gives creativity? What brings about creativity? There are plenty of theories being proposed by cognitive scientists about what gives creativity. I'm not an expert in those areas, but from my personal experience, a lot of the sort of research ideas that I get come from just adapting ideas or blending ideas from different domains, different areas, and putting them together and then creating something new. But of course in a coherent manner. So you're not just mashing things together and put something out. And creativity is really a hallmark of human intelligence. It's a trait that is uniquely human, and it's a trait that what makes us invent tools to help us do things. So creativity is a form of intelligence, it's a hallmark of intelligence. Artificial intelligence, AI. I'm sure this word is no foreign to most people nowadays, but it means a lot of things nowadays, what AI is. It could mean self-driving cars, or it could mean AlphaGo, a chess program developed by Google that beats professional players. Or it could mean facial recognition systems that are pretty popular nowadays. Now, these three things may look very different type of applications, but there are some common themes among these three things. The first thing is that they're all driven by a broad family of algorithms, what we call deep learning. Deep learning is what kick-started the whole AI wave in the past few years. A lot of things weren't quite possible until this broad family of algorithms, deep learning, started to appear. Self-driving car wasn't possible until a few years ago. And the second common theme of these three things is that they all are working on a particular type of problem that has a very explicit or objective. What I mean by that is that you can judge whether an AI or a model performing these tasks to be correct or wrong. A self-driving car, if you are not creating accidents, then you're doing well, right? For AlphaGo, if you're winning games, then you're good. For facial recognition system, you can measure accuracy, how accurate the system is in identifying faces. So it's not hard to quantitatively assess the performance or the quality of the system. So they're tackling on a very sort of objective problem. Now these problems are very different to another type of problem, what we call creative problems, like painting or poetry or music composition. Now, these problems don't have like a right-wrong thing. You can't say, say a system that can paint some painting to be painting correctly or wrong. You can't quite say that. You can say maybe some of the paintings are better than others, but there is a huge degree of subjectivity to measuring the quality. So these problems are a little bit different. They're not very objective. But we think these are the interesting problems that we should work on. Because these are the problems that lets us test the limits of AI. And what I mean by that is that we know deep learning models are very good at pattern recognition, which is why I can do things like recognizing objects in the painting, for example. But can they synthesize the knowledge and create something new? Say, create a painting. That's very difficult. That's not trivial. So it is for these reasons we find these creative problems actually even more interesting than just standard objective pattern recognizing problem. And because we do research in language, so my research is in this intersection between machine learning and natural language processing. So we thought we might do something a bit more creative in the language space, and poetry generation is sort of like a good sort of space to start with. Some of the research questions that we have is to do with creativity. We want to know whether machines can write poetry, or more specifically in language, whether they can create storyline, new storyline, novel narratives. But you may say this is all very interesting, sure, but still, what's the point, right? Because I can see how self-driving cars can help change our lives, but what is a poem generator going to do to, change your life? I mean, that's a fair point, right? I mean, if you write grants, you have to say why you want to do these things anyway. So you got to you got to give a better justification. So are we just trying to make poets jobless? As implied by this article, who wrote a bit about our research, titled "Move Over Shakespeare, this sonnet writing AI is the poet we need." No, we're not trying to replace jobs or displace people. No, that's not the point. Not that there's much of a career to begin with writing poems nowadays, but that's not what we're trying to do. When we say we try to build machines to write poetry, what we really mean is that we want to build computational models to write poetry. And why we do that is because we think building these computational models provide a window for us to look into our brains, to see our brains, the underlying mechanism, how we learn and use language creatively. In other words, what we're trying to do is to understand the software of the brain that deals with language, that handles language. So that is really the motivation why we do this. And then you may say, why do you want to do that? Well, because if you understand how humans use language, you can build better programs or better systems that can interact with people better. So you have better chatbots, better home assistants, things like that. So these technology ultimately flows down to systems that interact with people. But of course, secretly, I just think it's a lot of fun too. It's more fun than just recognizing faces, I think. But that's subjective. Now, once we decided we want to do poetry, there are lots of different types of poetries out there. We decided to stick with sonnets. Partly because sonnets is a fairly popular type of poetry, largely popularized by Shakespeare. And because it's popular, there's a lot of sonnets that have been written by people over the ages. So there's enough data for us to build computational models to learn from. Now, you may have learned about sonnets back in your school days, and to refresh your memory, this is one of the most famous sonnet by Shakespeare in Shakespeare 8, in Sonnet 18, Shall I compare thee to a summer's day? I'm not going to read the poem, but you get the idea what's a sonnet. So sonnets are unique in a way in that not only it has content that expresses rich emotions, it also has structure in the poetry. And what we call aesthetic forms. For example, it has certain rhymes. Rhyme is a form of aesthetic form. You can see some of the words, some of the sentence-ending words in a sonnet, they rhyme with each other, like day and May, or temperate, or date. And every line also follows this alternating stress pattern, what we call the iambic pentameter. What you see there is basically, the stresses for the first line. And the correct way, I was told, to read poems would be something like, shall I compare thee to a summer's day? That's sort of alternate. Maybe I'm exaggerating, but you get the idea. And poets put a lot of effort to try to not just write lines that express rich emotions, but also make sure that lines follow these sort of patterns, right? Like you have to know what words have these unstressed and stressed patterns, and so you string them together, it flows well. And these things is what make poetry very, very unique. So that brings me to DeepSpear. So DeepSpear, it's the computational model that we named for writing poetry. It's a mash of basically two words, deep learning and Shakespeare. I've talked about deep learning, and Shakespeare should be fairly obvious. So let's dive down into it. So this is the architecture of DeepSpear. Where should we start? Maybe this is a bit too much detail for a 20-minute talk. Let's make it a little bit more intuitive. Okay, we'll go through it at a slightly higher level. At a very high level, DeepSpear has three components: the language model, the pentameter model, and the rhyme model. The pentameter model is the model that's responsible for learning the stresses, the iambic pentameter, the alternating stresses that I just mentioned. So it needs to understand, by reading lots of sonnets, what are the words, what are the syllables, and then what are the syllables that are stressed, what are not stressed. The rhyme model is responsible for understanding or extracting what words rhyme with each other. So it should learn, after reading lots of sonnets, day and May rhyme together, for example. The language model is the core engine of DeepSpear. It is the core component that generates poetry. So the language model needs to understand how you string words together to form sentences that sound natural and poetic. And so, whether your system works or not largely depends on the language model. So the language model is the most important part. Now, you know the architecture a little bit on a high level, how it works. So how does it work? Well, we do what we call training by basically feeding lots of sonnets to DeepSpear. So DeepSpear will just read, these 2,600 sonnets over and over again to try to understand how to string words together, to try to understand what words rhyme with each other, and so on and so forth. And then once it's learned all that, then it can start automatically generate poems. Sounds easy. So does it work? Well, the first thing that we need to check is whether it's actually creating new poetry, right? Because, it can cheat by just memorizing the 2,600 sonnets and then just reciting it back to you. So the first sort of sanity check that we have to do is just make sure it's not doing that, and it's not. So we made sure it's actually creating new poetry, so that's good. And so then the next question is, are they actually good? At first, we tried to do it the computer science way. We tried to find some automatic way to judge how good sonnets are. But we failed. We realized it was just too hard. And so in the end, we realized ultimately for these problems, you just have to involve human to evaluate these things. So what we did is that we basically got onto a crowdsourced platform and asked people, what they think about the DeepSpear poems, but in a slightly more creative way. We frame it as a game, a bot or not game, where we present to users basically a pair of poems. You can see on the left-hand side and the right-hand side, 2 poems. And we ask people to just simply guess, which one you think is the machine-written poem. And then that was it, And what did we find? We found that basically people can't tell. The accuracy of people trying to identify the machine counterpart is about 50%, so close to pure chance. And so that implies, well, users are not basically able to tell apart between human poems and DeepSpear poems, right? So that means we're writing poems as good as Shakespeare. That's great, right? So we've taken over the world now, so the poets can retire, and so we don't need poets anymore. But wait, there's still something. We need to think a little bit more about this, right? The people who got on the crowdsourced platforms, they're just lay users. They're normal, everyday people. They're not literature experts. They haven't studied literature extensively. Should we at least consult some literature experts about, our poems to give a bit more, justification how good it is? So we did that. So we got our in-house literature expert, Adam. And we basically asked him to rate poems, or the poems on a number of qualities. The stress quality, the rhyme quality, the readability, and emotion. But a few things to note, because we want to reduce bias, we actually mix a bunch of human-written and machine-generated poems, and then we show it to Adam. And he doesn't know which poem is written by which. So he doesn't create this bias that, I'm reading machine-generated poems, so they're all bad, and all that. And so the good part, so we found that the lines generated by DeepSpear, they're very good in terms of stress. They really obey that alternating stress pattern and all that. And in fact, the stress pattern was even better than the human-written poems, looking at the ratings. And talking to Adam, he said actually that's not surprising at all. In fact, human poets intentionally break rules sometimes to create an effect. And in this case, our machines are just being too conforming. Like it tries to stick to the rule and then just make sure every line obeys the alternating stress pattern. And it's very regular. Same for the rhyme. It was really good. The readability is all right. It's not amazing, but it's okay. But the most important thing is that he thought the emotions were lacking in the poems. And because of these contrasting features, he was able to tell which poems are written by who. He was very sure, this poem is written by human, and yes, this is definitely a machine-generated one. So to him, it was day and night clear, which is which. So some takeaways. At the beginning of my talk, I was asking the question about creativity. We want to understand, can machines be creative? Or more specifically, in the language space, we want to know whether they can compose novel narratives or storyline. To a certain extent, I think our experiments show that it is a yes, because Deep Sphere poems were good enough to sort of fool like lay users, people like myself, who's not a literature expert. But you know, they weren't good enough for a learned audience. So if you read a lot of literature, you probably find they're just crap, right? But you know, we also found that the aesthetic forms, the structure, is very easy to learn. So the rhyme and the stress patterns, you know, the models have no problem learning that. But what makes a poem express the rich emotions that it does, that's really hard to learn. And I think it's not just about stringing words together to make something look natural. There's more than just that when it comes to conveying rich emotions. And we don't know at the moment how we do that. Now, it's been a long day, and you know, you probably won't remember most of what I just said, and if there's one take-home message that I want you to remember from the talk, is that AI isn't quite taking over the world yet, at least in terms of poetry writing, and so we can all relax. Thank you.